Hello, dear friends. Today we will discuss very important law, that is Wien's displacement law. So basically, in this video, we will see first background of this Wien's displacement law. After that, its application. Then a statement of Wien's displacement law. After that, its mathematical formula. Then its graph, and then its limitation. So we'll discuss everything one by one. So first of all, let us see the background of Wien's law. What is the background? So Wien's law is also known as Wien's displacement law. It is named after German physicist William Wien in honor of his extraordinary contribution in explaining black body radiations. Wien's law gives us a relationship between the wavelength of light that corresponds to the highest intensity and the absolute temperature of object. Very important. Wien's law gives us a relationship between the wavelength of light that correspond to highest intensity. It is a very important point, and the absolute temperature of the object. So basically, Wien's law explains the wavelength corresponding to highest intensity and its temperature, and at that instant intensity, the absolute temperature. Okay, so there are some applications. What are the application of Wien's law? First, it is we can determine the temperature of astronomical object using Wien's displacement law, like temperature of sun, star, etc. Then Wien's law is useful in analyzing black body radiation curve. Then it is used in designing remote sensor, and there are many more applications, but these are very important. Very important. Okay. Then let us see the statement. What is the statement? A statement of Wien's displacement law. So uh, it states that Wien's displacement law. What is Wien's displacement law? So it says Wien's displacement law states that the product of maximum wavelength, important point, maximum wavelength corresponding to maximum intensity and the absolute temperature is constant. This is the statement of Wien's displacement law. Mathematically, it can be written like this: lambda m or lambda max equal to b by t. This b is called Wien's constant. So lambda max is wavelength peak, b is constant of proportionality, that is also called Wien's constant, and t is absolute temperature, that is taken in Kelvin generally. There are some limitations. Before that, we will discuss the curve of Wien's law. So you can see this is the curve of Wien's displacement law. So you can see in this curve, this temperature is 7,000 Kelvin. You can see here, this is 6,000, this is 5,000, this is 4,000, and this is 3,000. Now you can see at higher temperature, the wavelength peak, this is wavelength peak, means wavelength corresponding to peak intensity, that is also called wavelength peak. So wavelength peak is shifted towards origin, means its value decreases. That's why this law is lambda max is equal to b by t, means lambda max inversely proportional to temperature, means we get intensity peak at shorter wavelength at given temperature. So this is the curve. Now you can see here decrease of lambda peak with increase in temperature. You can see if we increase temperature, lambda peak decreases. This for this temperature, lambda peak is slightly right side. If we increase temperature, lambda peak goes slightly left side. In this way, we can see for all that curve. Okay, so this is the graph of Wien's displacement law, and it is very helpful to analyzing black body radiations also. You can find black body radiation explanation in the description link. So now we will see the limitations of Wien's law. What are the limitations? What is limitation? Actually, however, we have to know that at very low temperature, a continuous Wien's curve cannot be obtained. Hence, when displacement law fails at long wavelengths, it is a limitation. It fails at long wavelength. So at long wavelength, you can see in this graph, the intensity peak we cannot